there, and welcome to the content highlights for Chapter 12.3 through 12.5. In this section, we will explore standard deviation, as well as solving problems using the normal distribution and Z-score table. First, let's calculate a standard deviation. On your math exams, you score 72, 83, 80, and 95. You find that your mean test score is 82.5, but are curious as to what the standard deviation is. Calculate the standard deviation of your math exam scores. Well, first, if they tell us that the mean is 82.5, let's make note of that and we'll come back to it in a few minutes. One of the best ways to calculate standard deviation, particularly if you enjoy visual, is using a chart to set these up. So what we're going to do is construct a vertical chart that sets up all of our data values going down. So we have here 72, 83, 80, and 95. They do not have to be in any particular order, so save yourself the hassle. Don't try and rearrange them. It's unnecessary. Now remember, the standard deviation formula is equal to the square root of the sum, that's what this stands for, of x minus x bar squared all over n minus 1. So let's break this down into a simple chart that just needs two more columns. First things first, order of operations tells me to complete the parentheses first, so I'm going to set up a column for x minus x bar. That means I'm going to take each of these numbers and subtract them by 82.5. 72 minus 82.5 gives us negative 10.5. 83 minus 82.5 is positive 0.5. 80 minus 82.5 is negative 2.5. And then we have 95 minus the 82.5, which gives us 12.5. Now that we've completed what's inside the parentheses, we move on to our exponents. That means I have to create one more column for dealing with this exponent. So that will be x minus x bar all squared. Now remember, we just calculated each x minus x bar. So to square these, you're going to take each of these respective numbers and multiply them by themselves. Negative 10.5 squared is 110.25. 0.5 squared is 0.25. Negative 2.5 squared is 6.25. And last but not least, 12.5 squared is 156.25. Now the formula says after you square those values, we're going to take the sum. So remember that this is a capital sigma, means to take the sum. So I need the sum of the x minus x bar squared column, which equals 273. Now we have enough information to plug into our formula. The standard deviation is equal to the square root of that whole numerator is 273, which is what we just found over here, divided by n is the number of data that we have, 4 minus 1, which is the square root of 273 divided by 3, which, if we keep simplifying, is the square root of 91, which is approximately, if we round that, 9.54. So what does that mean for us? Our math exam standard deviation is 9.54. Remember that the standard deviation measures the variation in your data. So it means your values vary by about 9.5 points based on how many standard deviations away from the mean of your data that you get. Next up, let's calculate a Z-score problem. Essentially, we're using what we know about the normal distribution in order to calculate the likelihood of its occurrence. So with this problem here, the mean cholesterol level in children is 175 with a standard deviation of 35. Assume this level varies from child to child according to an approximate normal distribution. What is the probability that a child has a cholesterol level that exceeds 200 milligrams? Well, they told us that our mean is 175 with a standard deviation of 35. Now, in order for us to calculate this, let's draw ourselves the normal curve to get a little bit of a visual of what's happening here. So if our mean is in the center, and we want to know what's the probability that it exceeds 200. 200 is right around here, exceeds with shade to the right. Now remember, the probability is always the area under the curve when you're dealing with this type of distribution. So the probability of it being greater than 200, exceeding 200, is the area of this shaded region. Now, I don't know about you, but we don't really have a fancy formula at this level of math to calculate that, so we have to first find a z-score, which will convert everything into percents for us. Our z-score formula, recall, is equal to your x value minus the mean divided by the standard deviation. So in this case, the z-score equals 200 minus 175 divided by 35, which when we round that, we get 0.71. Now, the positive or negative outcome of a z-score dictates which side it's on. If your value is on the right side, it should be a positive z-score. On the left side should be a negative z-score. Once we have our z-score, we can go ahead into our z-score table, which in our book is 12.14, so table 12.14. And what we want to look for is the closest z-score we have to 0.71. Now, if we go down our list here, it's in a little bit of an order. We have 0.70 and 0.75. 0.71 is closer to 0.70, so we're going to use the percentile of 75.80. So this is 75.80. Now, because when we look things up, this table is referred to as a cumulative table, a percentile table, it's calculating things from all the way at the left up to that point, which means that to the left is 75.80%, but we want the area in this tail region. To calculate a tail region, you always take 100 because it all adds up to 100%, and then subtract the area on the left side, which is 75.80, giving us a probability of 24.2%. Next, let's take a look at calculating a z-score, or calculating a probability rather, when you are looking for the probability of something occurring between two amounts. So in this example, we have the same mean and standard deviation as the previous problem. The difference here is we want to know what the probability is that a child has a cholesterol level between 175 and 200. So if we draw our picture here, we still have 175 in the middle because that's our mean. We still have 200 to the right of the mean, but this time we want the probability that it's between these two numbers. To calculate a probability between two amounts, you have to find their z-scores respectively and then look up their percentiles, followed by subtraction. So first, on the previous page, that example that we did, we found that the z-score for 200 was equal to 0.71, which gave us an area of 75.80. Now, let's calculate the z-score for the other value here. 175 minus 175 divided by 35 is equal to 0. A z-score of 0 is a percentile of 50. So in order to calculate the area between them, subtract these two numbers. Remember that you should always get a positive value. So it's the bigger number, 75.80, minus 50, which gives us a probability of 25.80%. If you ever find a negative probability, it means that you had your numbers backwards. That's one of the mistakes that could have occurred. But probabilities can only ever be between 0 and 100%. So that's one tip-off that you may have an error in your problem. Thanks for watching.